Greetings and welcome, friends. Mr. Waddy here. We're talking about exponential functions. This is just a little review packet that we did before the test, and I just want to take a look at a handful of these problems. So first of all, I pre-graphed a parent function for us, and this parent function happens to be, well, let's see if we can guess it, actually. The value of a is at 1 times. And the value of b, well, let's find out what it's doing. Let's find some lattice points here. To go from 1 to 2, and 2 to 4, and 4 to 8, it's doubling. So that means the value of b is 2, and it's raised to the x. So that's my parent function. But now I have to be able to identify what are these things doing to it, and figure out what that is in terms of transformations. So, well, let's actually write my same a, h, and k. So a was equal to 1 here, and you might wonder, looking at this, I don't see an a, and a is actually an invisible 1 hiding in front of that. I know, it's crazy. B is going to equal 2. I almost said c. H is the opposite of this, so h is positive 4. And k is the same as this, so that's -3. So what do this h and k do to my parent function? Well, what it will do is the h behaves as a horizontal shift. That's a horizontal shift. I've already accounted for the opposite piece here, and positive x values are to the right, so this is going to be a shift to the right 4 units. And the k is going to be a vertical shift. You might even remember these back from when you were graphing absolute value functions. And a -3, negative y values are down, so that's going to be down 3. So let's take some of these points. Actually, let me get myself another point or two here. So b was equal to 2 for this parent function, so to go right, I was doubling and going over 1. So to go left, I have to divide by 2 over 1. So here's a half. Divide a half by 2, I get a quarter, etc. So let's move by the h and the k. So I'm going to go over 4, and that's right off my graph, and down 1. Here's my new point. For this one, over 4 and down 3. And here's that point. Over 4 and down 3. Here's that point. And I'm getting my new points. Oh, so lovely. Wait a minute. What did I do? What did I do? I went down too much on that last one. There we go. Over 4, down 3. So this is half height. So over 4 and then down 3 full units. It's landing at a half height. Now, my original function had a horizontal asymptote, right, where the graph gets closer and closer and closer and never hits it, at y equals 0. Now, the h, if I horizontally shift a horizontal line, you won't notice a difference. But if I vertically shift a horizontal line, it will be noticeable. It's going to shift that down 3. So instead of y equals 0, my new asymptote is y equals -3. So I'm gonna use that to help my graphing of this. And also, I like to graph these upside down sometimes when it's a growth function. So let's see how well I can hit these points. And I'm not interested in your ability to hit those points perfectly. I'm interested in your points selection. Okay? So let's flip that back. There we are. So that is the new function that's been translated by these translations from the parent function y equals 2 to the x. Now, they did ask us for domain and range. So for domain, shifting it 4 to the right, well, I had infinitely left and right before, so the domain is all real numbers. It's everybody. But the range actually has some interesting behavior. So this was shifted down 3. And notice the points in which this purple graph exists is everything bigger than -3, because this graph does go infinitely high. So the way we describe that is the set of all y such that y is bigger than 3. Okay, and there we go. That's not bad. So there's my new domain and range. The domain and range for the blue function, domain would have still been all real numbers, and the range would have been everything bigger than 0, so y greater than 0. All right, let's take a look at another one here. All right, write and graph an exponential function f represented by the table, then compare the graph to the graph of y equals 1/2 to the x. Okay, so let's see if we can identify A. I'm assuming there's no h and k transformations on this. So the first thing I'm going to notice here is that my y-intercept is at 2. That means A equals 2. To find B, that's going to be my growth factor. And these are equal increments horizontally. They're over 1s. So to go from 2 to 1 and 1 to 1/2 and 1/2 to 1/4, it looks like it's dividing by 2 repeatedly. But since the B value in my general form for these is always multiplied by it, B is going to equal 1/2, what that's going to be. So let's see if we can graph this and compare it. So, well, actually, we'll write the equation first. Oh, I can even call it f of x if I want. Yeah, ooh, they called it f. So f of x equals 2 times 1/2 to the x. So if I want to graph this, here I graphed the other one already. So my new y-intercept is at 2, and it is still has a 1/2 value for b. So it's actually decay. It's not growing so well. So go divide by 2 and over 1 lands me here. Divide by 2 and over 1 lands me there. To go backwards, the opposite of dividing by 2 is multiplying by 2. So 2 times 2 is 4, and backwards 1 lands somewhere like that. And if I draw that, something like that. Now they asked me to compare it to the original function, or the function of y, g of x equals 1/2 to the x. The value of a, the starting value, was changed to 2. I could also kind of describe that as the y-intercept, but the growth factor remained the same, and those the rest of the graph kind of behaves the same. Now it's steeper here than it was there, but that's because of the way that it ended up working out. Let's see. Determine whether the table is exponential growth or decay or neither. The question is, I've got to figure out what b do I multiply by, right? Multiply by b, if it is in fact exponential. And so I can actually set that up. Let's compare a couple of these. So 162 times some unknown b value is equal to 108. And if I want to solve for b, I can just divide both sides by 162. And so that means b is going to equal 108 divided by 162. I get a decimal of 0.6 repeating, which I happen to know is 2/3. So I get b equals 2/3. Let's see if that works on a couple of these other ones, just to kind of make sure. So 108 times b, or actually, oh, let's test it. Yeah, 108 times 2/3. What's that equal to? And we're hoping it's going to equal 72. So multiply by 108. And I do, in fact, get 72. So it does appear to be exponential. That's true. Because it's got repeated multiplication. So it is exponential. Because of repeated multiplication. And is it growth or decay? Well, the fact that my b was between 0 and 1 means that this is decay. Because b was between 0 and 1. Or, since in this unit we were technically, once we were talking about growth and decay, we were technically thinking of this function, a times 1 plus or minus r to the t. and this 1 plus or minus r is equivalent to your b value. So I found b is equal to 2/3, and yeah, that's less than 1, so it's decay. If I wanted to find the r value, I know they didn't ask us for that, but let's just find it for fun. Because this is less than, I know that it's a minus version of this function. So I would have 1 minus r is equal to 2/3. Let's see, I might need to write this over here. So if 1 minus r is equal to 2/3, I could subtract 1 from both sides, which is the same as subtracting 3/3, actually. So minus r is equal to negative 1/3, or, where's my slider here? R is equal to 1/3 in a decay situation. Okay, so it's reducing by 1/3 each time. Or I could say, in this sense, only 2/3 remains after each horizontal move. Okay, exponential growth or decay. So the value of b is 0.84. So it's going to be decay, because that's less than 1. The value of r is going to be exactly what I just did a moment ago. 1 minus r is equal to b, so that's equal to 0.84. Subtract 1 from both sides. I'll have minus r is equal to 0.16. Negative, sorry. So positive r is equal to 0.16. So that means r is a 16% decay rate. Okay, that's that. Let's see, last problem. Value of a TV is $1,500. That's my starting value, so A is equal to 1,500. The value decreases, okay, so that's giving me clues right there, by 14% each year. So that means R is equal to 14%, written as a decimal is 0.14. It says write a function that represents the dollar value Y of the TV after T years. So we'll do it in purple, why not? So Y equals 1,500 times 1 minus 0.14 to the T. 1,500 times, that's going to be 0.86 to the T. And that's what we've got. It says graph the function. Oh, approximate the monthly percent decrease value is T. Oh, T reviews. Goodness. So if it's decreasing by 14% per year, if I divide that by 12, that's about 0.0116, or 1.16 repeating percent per month. Okay. And then they ask us to graph this. So it starts at 1,500. Ramp. Here's my starting value. My t-axis, or my x-axis, is in years, and it's going to have a value that is 86% each time. So what I'm going to actually do is take 1,500 in my calculator, multiply by 0.86, and so it's going to go down to 1,290 in the first year. There's a point. This is year 1 right there. Multiply 1,290 times 0.86. I get 1,109.4. Here's 1,100. 9.4. Going to be close enough. Like that. Multiply that by 0.86. I get 900. So here's the 900 line. Over 1, 954. And this isn't changing by a lot. Again, I get 820. Here's 820.5. Then I get 705.64. So here's 700. 705.64. Next I get, and all I'm doing is multiplying by 0.86 over and over. I would then get 606.85, right? And I've got like 100 units in between there, so I don't really have a lot of way of making that very accurate. And let's see, another one, 521, right there, and then 448. I'll just go out to this far, 448. And so it is decreasing. It's not quite linear. I'm not going to be able to draw this. Ugh. You get the idea. But it's doing something like that. And then they ask us to estimate the value of the TV after 3 years. And I actually had the exact value a moment ago, but let's say I was reading this off the graph. So I would find 3, and I would have read it off of the graph. They said estimate. Right, so I would have read this, I would have read up from 3, and then across to the y-axis. And that is, right, maybe I would have estimated it about $950 after 3 years. All right, well, thanks for watching. Have a great day.